Welcome to the documentation coding example for the linear regression section of the course. While it may not be super interesting, understanding how to read and reapply documentation examples will rapidly speed up your own learning process. Let's walk through the linear regression documentation example together. In the browser I'm about to jump to, I'm going to have several tabs open. Those are going to include the documentation page, the data page from the documentation, linear regression example.ipynb, that's the notebook file for what we're actually going to be going through, and then a new untitled notebook, which is what I'm going to be coding in for this lecture. Let's hop over to the browser and get started. Alright, so here I am at the ML guide. This is the machine learning library documentation guide page. If you come over here to classification and regression and click on that, you'll be taken to this page, and then scroll down until you find linear regression. Click on that. And this is the documentation example we're going to be working through. If you click over here on Python, there it is, the documentation example. It's pretty simple, so the main idea here is to try to get an idea of the workflow for dealing with machine learning algorithms with Spark. And we're also going to expand on this documentation example just a little bit. If you come to, in your notes for the course, Python and Spark for big data, Spark for machine learning, and then the linear regression folder, the notebook that has everything that we're going to be working through is linear regression example.ipynb. So that's over here. If I click it open, you can see that there's some text notes and then all the code. In case you ever want to reference anything that we're doing, you can just copy and paste from this notebook. And then if we come back here, we also have the sample linear regression data text. That's the actual documentation text file. And I've already downloaded for you. It looks like this. So this is the actual text file we're going to be working with. So let's hop over to this new notebook that's untitled and get started. So the very first thing we need to do is actually start a session. I will say from pyspark.sql, import the Spark session, and let's create it. We'll say Spark session, builder, app, and I'm just doing tab there to quickly autocomplete that. I'll create one called LREX, and then I'm going to get or create that Spark session. Hit run. And then whenever you're working with machine learning with PySpark, what you end up doing is you say from pyspark.ml dot, and then if you hit tab here, you essentially see the families of machine learning that is available to you. So classification, clustering, evaluation, pipelines, etc. We're going to be dealing with the regression family. And then I'm going to import an actual regression algorithm. If you hit tab, you'll see various options here, but we'll eventually just choose linear regression. So run that. The next step is to actually load in our training data. So I'm going to make training a new variable, and I will say Spark read. Now we've read in CSV files and JSON files. We're going to say .format, which is the generalized version, and instead of passing in CSV, the actual data is in this form called libsvm. So if you look at the data, the actual page I have it open on, you can see here we have this libsvm format. So this is the format it's in, so that's why we have to read it this way. And I'm going to say libsvm, and then .load, and then the actual text file. So sample linear regression data. So we run that, and let's actually see what the data looks like. So we have a label column and a features column, and this is the actual format Spark needs in order to run a machine learning algorithm on it. Now in real life, most of your data isn't already going to be conveniently formatted this way, but we'll discuss that in the next lecture where we do a code along through a more realistic data set. But all the documentation examples come with data that's already formatted this way for you. But keep in mind that this label column needs to have some sort of numerical label, and that will be either a regression numerical value or a numerical value that matches a classification grouping. The feature column has inside of it a vector, and that's a vector of all the features that belong to that row. Usually what we end up doing is combining the various feature columns in a realistic data set into that single features column, using the data transformations that we're going to be learning about later on. Now let's continue working through this simple example. The next thing we want to do is actually create an instance of our model. So we say LR is equal to linear regression, and then close parentheses for the very basics, but I want to talk about three parameters, and those are the features call parameter, which tells this model what is the features column called. Now by default, this is just features. But in case you forget that and you actually call this something else, maybe call it my features or house features, etc., you could just pass that in as a name to be expected. So default is features, so we'll leave that in. The label column name that we expect is label. Again, that's the label column here. And then the last argument we can provide is the prediction column. And what's the name of the actual prediction? So default is prediction. But again, if you're dealing with something like housing prices, you could say, oh, house price prediction here. So once you actually evaluate some data and it has some predicted values, it will label that under a column called prediction. So we'll run that. And then the next step is to actually just fit or train the model. So we will say LR model. So that's just some variable. And we'll say LR fit. And we're going to fit onto the training data. And this should actually probably be snake casing, but for now we'll just leave it that way. And that may take a little bit of time depending on how fast your computer is, especially how fast or how large the data set we're working with is. But here we have LR model, and it's been fit to the training data. So now there's a lot of information we can grab off this model. So I can say LR model, and I can actually grab the coefficients off the model. Those are the coefficients for that linear regression, and I can also grab the intercept. So I can say intercept and grab that intercept. So if in case you're interested in how these coefficients actually relate to the model, essentially these coefficients correspond to a particular feature. And you can do the reading in Introduction to Statistical Learning in case you want to learn more about the mathematics behind relating coefficient to something like feature importance. All right, now let's talk about the summary attribute, which contains even more information. For this, I'll create a variable called training summary, and I will set it equal to the summary attribute off this machine learning model. And from this training summary, I can call lots of attributes and methods that are really useful. So for example, I can call the r² value, where r² just explains or tells you how much variance is explained by your model. This data is kind of wacky, so we actually don't get a very great r² value, but keep that in mind that that's available to you. And then more conventional things like root mean squared error, that's also available to you. Basically, any general linear regression error metric is here available for you. Now, we've actually committed kind of a big mistake. We never really separated our data into a training set and a test set. And the reason for that is because the documentation kind of glosses over that and never actually does it. So what we ended up doing right now is we trained on all our available data. That's something we generally actually want to avoid doing. Instead, we want to do the train test split that we discussed during the Introduction to Machine Learning. We want to train on some training data and then evaluate our model on that actual test data. So let's show you how you can actually do a train test split. I'm going to create a variable called allData and say spark read, and I'm actually going to read the exact same data in. I'm just calling it allData now, so this is kind of a more realistic situation. All right, so let's imagine that we just pulled in all that data. Now, how do we actually split that data into some training data and some test data? The way you do that is by calling random split, and that's actually a method available on any data frame. So we say all data, random split, whoops, should be lowercase. And then inside of this, you pass in a list. And the list just dictates how the split is done. So the first item or first data frame out will have 70% of the data, and the second data frame out will have 30%. So let me kind of do a little example here. I'll call this split object, the result of this. And now let's check out the split object. What does it actually look like? Well, it's actually a list of two data frames, where the first data frame in this list has 70% of the data, of all that data, and the second data frame in the list has 30% of all that data. So usually, however, you won't put this in a split object. Instead, you'll do a little tuple unpacking, and you'll say train data, test data. So now I dictate that, whoops, spelled that wrong. Now I dictate that train data is 70% of all this data, and that test data is 30%. And this is randomly split for you, so you don't need to worry about that. What you don't want to do is just grab the top 70% and the bottom 30% in case by accident your data has been sorted. But instead, you actually just want to randomly grab 70% of the values, stick them to training, add 30% of the values, and then stick them to test data. So let's run this. And now what we're going to be doing is working with that train data and that test data. So again, this is just, if we kind of show this again, this is, whoops, I spelled that again. There we go. This is just the actual label and feature. So this looks exactly like the data we had before, but if we take a look at describe show, note that the training data has 349 count. If I look at the test data, so I say describe show off of that, this has 152. So 30% is to the test data, 70% of it goes to training. Okay, let's continue on and show you how to actually deal with these. So what we can do is let's create a new model. We'll call this correct model, and I'm going to fit it to that training data. And then once that is done running, now I actually want to evaluate how well my model did, not on training data, but instead on that test data. So what I end up doing is say test results is equal to that correct model, and I call the evaluate method off of this. And inside of that evaluate method, I pass in test data. And now off these test results, I can grab anything I want. So I can grab those residuals and show the actual residuals between what the model expected versus the labels that I actually knew for the test data. Or I could do things like the root mean squared error. And then it gives me that back as well. So what's the difference between what we just did versus what we did before? Well, in our case, using evaluate on the test data, it means that we're actually comparing our predictions to the labels that were already assigned in the test data. So you do this a couple of times, maybe you add in more parameters into the linear regression model. So if you come back up here when you actually created that model, so if we come up to LR model, LR here, so linear regression, if you hit comma, there's actually other things like elastic net parameters, fit intercept, max iteration, regularization parameters, a lot more stuff that we can discuss later on. But basically the next step after you do that is to try to mess around with those parameters, see what works, see what doesn't, and then reiterate on this process until you have a model that you feel comfortable with. Once you do that, the model is ready for deployment. Now you'll usually deploy your model on data that has no label. Otherwise, what would be the point of deploying the model if you already had the label? So let's kind of mimic that by creating an object called unlabeled data. And I'm going to set it equal to the test data. And I'm going to select features. So if I look at this unlabeled data, if I just show it here, note that it's only the features column. So this doesn't have any actual labels. So this is essentially unlabeled data, and our model is ready to be deployed on this unlabeled data. So now we're ready, for example, to predict on housing prices for houses that we don't have a price for yet. So we come down here, and then what we're going to end up doing is we use the transform method. So I'll create a data frame called predictions. I call my corrected model. I say transform, and I transform on that unlabeled data. So instead of evaluating, now I can transform. And then if I check out predictions, I have features and prediction. And now this is the predicted value based off of these features. And there's no way I can really evaluate this as far as R squared or stuff like that, or the root mean squared error, because this data was unlabeled to begin with. So I have nothing to really, I have no correct values to compare it to. That's the kind of thing I had to take care of back when I had the test data. So this is kind of on the model deployment phase. All right, so hopefully that gave you an idea of how the actual workflow for a machine learning algorithm with Spark is intended to be used. Don't worry if you didn't catch every single detail. We're going to be working on a much more realistic example up next, and that realistic example will help your mind kind of connect features to actual things in real life. So hope you understood the general workflow, just the general idea of how things are done here. In the next lecture, we're going to clarify a lot of this and also show you some pre-processing steps that you'll probably have to run into in the real world. Thanks, and I'll see you at the next lecture.